All right, last thing, and then we have all the topics covered for this week, methods. And then you guys can jam on that homework. Moment generating function method. My favorite, actually. I don't know if it's Colonel Watts, as she walked out of here kind of happy. So maybe it's her favorite too. Moment generating functions are like Taylor series or series solutions to differential equations. They're a way to look at something in terms of a series. So if you don't know a distribution, you can run the first few terms of a moment generating function, and it'll tell you something about that distribution. Same thing as if you are in, I don't know how much you guys use it in your modeling classes, but you should see it in numerical analysis, interpolating functions and things like that, where you're approximating functions by series. So you should see that. And definitely, if you're in real analysis, it's the high point of that class to prove things about Taylor series. So that it's related to that idea that you're approximating things by series. So how do you do a problem with a moment generating function? There are two of you guys in here did it for the last, very beautifully on the last homework. Aiden and Jake did it on the last homework, where you guys looked at, I think it was number 8, number 9, one of those where you're given a moment generating function. They just went to the back of the book and they looked up in a table. They saw the moment generating function was one of the well-known ones, and you can get everything from the back of the book. So in the back cover of your book is bring your book to the WPR, because in the back cover you have a little table of known functions. And on the side of that rightmost column, there's the moment generating functions. And so that's where you recognize a series. Like the series for e to the x looks this way. So the moment generating functions have this, they come from this one function. They actually converge. So here, what you're given is a known distribution. I can actually see Colonel Watts making up a problem like this. You're given that z is normally distributed. So z is a random variable. It's normally distributed, has mean 0, standard deviation 1. You're given another function in terms of z squared. And you're asked to find the PDF of z squared. So I'm not sure in your homework. I'll let you take a look at it since I'm blasting through this stuff. So you probably will have time to look at your homework today. So if you look at your homework, or they say something has a specific distribution, you can use this. So for the first step is to find the moment generating function of the transformed variable. So how do you do that? You plug it right into the definition. So I'm asking you actually to cite things. I cite things for you too, so that you know where I got it from, so that if you need it, you can see it. So here I start. What's the moment generating function of z squared? That's the definition. It's the expected value of e to the t z squared. That's definition 4.14. And then somewhere in the book they have how to actually calculate it, but I randomly went through the book and I saw on page 203 that this is equal to this. So you can find it. It's in there. And then f of z is this guy right here. That's a definition of normal distribution with z squared replaced, right? And then I get down to here, and I have to do that integration, which I put it on Maple, because I don't have my license for Wolfram Alpha, none of them worked yet, so I have to go either turn on my computer. The same thing you guys have to do. So I just opened up what I had. Wolfram Alpha wouldn't actually do it, so I went to Maple. And it gave me a function. So if you're not familiar with Mathematica, I would do these on Mathematica to make sure that I can do them, not try it, open it for the first time on the WPR. Make sure you know how to run that. Then you go into the back cover of your book. If you have your book, open it. By the way, on the iPad version, on the ebook, do you guys have back covers in that one too? Yeah, make sure that that it's in there, because if it's not in there, you'll want to bring your regular hardcover book. But in the back of the book, they have a bunch of functions. It's a column of things. So look at it, Freddie, and see. So you see that table? Right at the end, you have moment generating function. You just go down and say, which one does mine look like? Right there. Looks like that one. See it? So it turns out that in the back of your book, if you look up moment generating functions, it looks exactly like the moment generating function for the gamma distribution with beta equals 2 and alpha equals 1/2. And then you just write down the PDF. They have the PDF in the table too, with beta equals 2 and alpha equals 1/2. So you plug those guys in. And this one Mathematica would do. I could crank it out on Mathematica. It gave me an approximation for this gamma of 1/2. So I could plug those numbers in. And then I have the PDF for that guy. So you can see why I like them. I like this because it's, if someone tells me there's some easy way to do things and it's legit, it's in the book, I'm going to pull it and see. And this is like too easy. So I'm not covering every single thing that's in this section. It has a bunch of theorems in there. Put those in your brown bomber because any one of them can be used. A quick way to get the expected value given a moment generating function. Has a bunch of them. There's one, theorem 6.3, I thought could be used quite a bit. So put those in your brown bomber, go through those examples. It doesn't make sense for me to do every single example. I kind of gave you a strategy of how to for each one of these. Okay, any questions? That was lightning fast. I just went through like 4 sections or 2, like a whole bunch of stuff all quickly.
Yeah, would you mind going back to the moment generating function?
Right up here?
The green.
Yeah, I put those in. I put these in here so because if you're going to get something different, so you need to know where I got those things from so that you can change what it is.
And so for this question, the thing we're supposed to find is PDF, correct?
Yeah, so in this one you're supposed to find the PDF. But once you find the PDF and you have the distribution function, you can come up with everything else that you need to come up with.
Right, but this one we're starting off with the moment generating function. PDF off of that.
No, no, they give you a known distribution. So the trigger word for using this method is that they give you a distribution that you know something about. That means the back of the book has all that table. So if they say normal distribution, you know almost everything about it. You can go to the back cover of your book. That would be the trigger.
So in this instance, couldn't we have just gone straight to the, couldn't we just reference the normal distribution PDF to the back of the book rather than?
No, because they ask you to transform it. So you know this is your known distribution, but they are asking you about the distribution for z squared. So you can't do that. But that's a good point. Like, what if you went moment generating function method and it turns out to be a rabbit hole because you get to this point and it's nothing in the back of the book? I think anytime that you have normal distribution, gamma distribution, any one of those known ones that they tell you something and they have a nice continuous transformation, like this is a parabola, they're just transforming it. Anytime you have something like that, that's a trigger that it might be best done with a moment generating function. And if it doesn't go well for you, like if you go down there, you get up to this point, and you realize, hey, I don't know what that is, there's nothing in the back of the book that matches this. Say, I went down this path, give me some partial credit.
What if you, like, say you didn't have to, like, you can't refer to the back of the book, and you still have to, like, do it using this method?
Well, you might not have time because this takes, you only have 55 minutes.
And I'm wondering, because, like, this basically, like, you need the reference to do anything like this.
Mm-hmm.
Okay, I was just making sure. I thought, like, there would be a case where you have to just use like the moment generating function definition to like go back and find the PDF. But if that's not the case, it's fine.
Let me think about a way that you can dig yourself out. So if you went down this path, there might be a way you could give the partial sum of a series and say, well, I can't give you the PDF, but I can give you the first 4 terms in the series that gives you the PDF. So you could probably do something like that.